Find the values of k for which this line cuts this curve in two distinct points. So first of all, given that these are intersecting, we need to find where they intersect, which is solving these equations simultaneously. To do that, given that they're both equal to y, we're going to put them equal to each other. So 2x plus k plus 2 is equal to 2x squared plus k plus 2x plus 8. This is a quadratic in x squared, so we're going to rearrange it and simplify it into a quadratic form. So to do that, I'm going to subtract everything on the left-hand side and put it onto the right-hand side. So I've got 2x squared plus, and I'm going to expand this out a little bit, kx plus 2x plus 8, and then take away 2x, take away k, and take away 2. Simplifying, 2x squared, now I've got kx plus 2x minus 2x, so I've just got kx left. I've got 8 minus 2 minus k, so that is plus 6 minus k as my constant term. So here's my quadratic that I get when I put these two equal to each other to find where they intersect. And the fact that it has two distinct points of intersection means that this quadratic, the discriminant, must be greater than 0. The discriminant being greater than 0 means there are two solutions to this quadratic, which means there are 2 points where they intersect. So given that the discriminant is greater than 0, we know that b squared, which in this case is just k squared, minus 4 times a, which is 2, times c, which is 6 minus k, must be greater than 0. K squared minus 4 times 2 times 6, that's minus 8 times 6, so minus 48. Then minus 4 times 2, so minus 8 times k, so that's plus 8k is greater than 0. Rewrite that in a form we're more used to. And now we have a quadratic inequality that we need to solve. To solve this quadratic inequality, I'm going to find the critical values, and to do that I'm going to factorize. Multiply to make 48, add to make 8. So perhaps I'm looking at 12 and 4. So it would be plus 12 and minus 4, so that when they add together I get the positive 8. So my critical values are when k is equal to minus 12 and k is equal to 4. Because this is an inequality, I'm going to sketch the graph quickly to see when it is what I want. It is a positive quadratic going through negative 12 and positive 4. When is it bigger than 0? It is bigger than 0 up here and up here, which means for these values of x and for these values of x, or k. So our solutions are when k is greater than 4 or when k is less than negative 12. If k satisfies either of these, then this line will indeed cross this curve 2 times. So if we visualize this problem, we have our quadratic and our straight line function, our linear function here. And our value of k is going to vary. We're going to see what happens as we change the value of k. So we can see at this point here, they don't cross at all. As we increase k, they get closer to each other, and again, and then k equals 4, they touch just once. It's a tangent. That was our critical value. If we go above 4, we now see that they intersect twice, and that's going to keep going. They're always going to intersect twice, no matter how far up that goes now. If we go the other way, we can see that at first they seem to be getting further away from each other, but then this quadratic seems to start coming down again, and it's getting closer again, and at minus 12 we hit that critical value where there's one solution, it's a tangent, and then when we go beyond there are two solutions again, and there keeps being two solutions as k gets more and more negative. We have to make sure though our inequalities are strict inequalities, they do not include negative 12 or 4, because those ones do not give two intersections, they only give one. But that should come through providing that you solve the inequality using the correct inequality symbol, the greater than symbol, not the greater than or equal to symbol.